Assalamu alaikum everyone. This is Mr. Abdul Qadir Goni. Welcome you all in Goni's classroom. Today we are going to discuss about total internal reflection and its uses, which is discussed in the chapter 12 of Edexcel IGCSE 91 Physics. And chapter 12 contains light waves. And in this chapter we have total internal reflection. The topic total internal reflection and its uses will be discussed now, and I'll be explaining this topic in a bilingual speech, that is, I'm speaking both in English and Bengali. Okay, before understanding total internal reflection, we must understand the conditions required for total internal reflection. Total internal reflection is sometimes addressed as TIR, as its short form, total internal reflection. And for total internal reflection to occur, these two conditions must be satisfied. The first one, light must travel from an optically more dense medium to an optically less dense medium, or we can say that from a medium of higher refractive index to a medium of lower refractive index, and the angle of incidence must be greater than the critical angle. So first we have to understand what is the critical angle, and critical angle is defined like while light passing from a more dense to a less dense medium, while light passing from a more dense to a less dense medium, the angle of incidence for which the angle of refraction is found to be 90 degree is called the critical angle. Okay, আমরা যদি এই ডায়াগ্রাম গুলো দেখি তাহলে আমরা এখানে দেখতে পাচ্ছি যে light, in the first diagram, light is traveling from glass to air. Glass is optically more dense medium than air, and in this diagram we can see that the incident ray is striking the boundary between the two media with an angle I, which is smaller than the critical angle. Okay, so when the light strikes the boundary between more dense to less dense medium with an angle that is smaller than critical angle, the light is refracted strongly. This is the light is refracted strongly, strong refracted ray, and we know when light travels from a more dense to less dense medium, it bends away from the normal. Okay, in this diagram some light is also reflected, weakly reflected, and you must remember that whenever light strikes a boundary between two media, some light is reflected as well, whether the reflection is weak or strong. দেখো লাইট যখন এক মিডিয়াম থেকে আরেক মিডিয়ামে যাওয়ার সময় মিডিয়ামের বাউন্ডারি স্ট্রাইক করে তখন লাইট সব সময় রিফ্লেক্টেড হবেই। রিফ্লেকশন ইজ আ মাস্ট। এখন যদি রিফ্লেকশন না হতো আমরা গ্লাস কিন্তু দেখতে পেতাম না। গ্লাস থেকে যত ট্রান্সপারেন্টই হোক না কেন, হাউ ট্রান্সপারেন্ট ইট ডাজন্ট ম্যাটার, সাম লাইট মাস্ট বি রিফ্লেক্টেড। তো যখন ইনসিডেন্ট রেটা বাউন্ডারিতে ক্রিটিক্যাল অ্যাঙ্গেলের থেকে স্মলার অ্যাঙ্গেলে ইনসিডেন্ট হয়েছে তখন স্ট্রংলি রিফ্র্যাক্টেড হয়েছে এবং উইকলি রিফ্লেক্টেড হয়েছে। এখন যখন ইনসিডেন্ট রেটা বাউন্ডারিতে ক্রিটিক্যাল অ্যাঙ্গেলে ইনসিডেন্ট হয়েছে তখন উইক রিফ্লেক্টেড হয়েছে, আবার স্ট্রং রিফ্র্যাকশন হয়েছে। কিন্তু স্ট্রং যে রিফ্র্যাকশন হয়েছে সেখানে দেখা যাচ্ছে যে the refracted ray runs along the boundary, that is the angle of refraction. Okay, this is not angle of refraction. Angle of refraction is always measured from the normal, and the angle of refraction is actually in this case this one. This is 90 degree. The angle of refraction is 90 degree, and for the angle of incidence for which the angle of refraction is found to be 90 degree, this angle of incidence is called critical angle. Okay, so defining critical angle, we can say that while light passing from a more dense to a less dense medium, the angle of incidence for which the angle of refraction is found to be 90 degree is called the critical angle. And obviously, angle of incidence and angle of reflection must be equal to each other. Therefore, if this is angle C, this will be angle C. And in this case, when light is striking the boundary at an angle that is greater than the critical angle, no refraction occurs. The light is totally internally reflected. This is called total internal reflection. Okay. In this case, the light is striking the boundary with an angle that is smaller than critical angle, and the light is strongly refracted and weakly reflected. And when the incident angle is equal to critical angle, the angle of refraction is 90 degree. And when the angle of incidence is greater than the critical angle, no refraction occurs. The light is totally internally reflected. This is called total internal reflection. So when you are asked to define total internal reflection, first you have to understand critical angle. Okay, so defining critical angle, we will say that the angle of, while light passing from more dense to less dense medium, the angle of incidence for which the angle of refraction is found to be 90 degree is called the critical angle. And when the light is incident at an angle that is greater than the critical angle, the light is totally internally reflected. Okay, so what will be the definition of total internal reflection? While light passing from a more dense to a less dense medium and strikes the boundary with an angle that is greater than critical angle, the light is totally internally reflected. Okay, এখন আমরা critical angle আর refractive index এর মধ্যে একটা relation build up করব. Okay, relating critical angle and refractive index. Okay, there is a relation between the critical angle C and the refractive index N. You must know that the critical angle is, in IGCSE, critical angle is denoted with the letter C and refractive index with N. Okay, then N is equal to 1 by sine C, or you can write sine C is equal to 1 by N. And critical angle for typical glass is about 42 degree. When you are asked to calculate the critical angle or refractive index given the critical angle, suppose আমরা একটা example দেখি. মনে করো there is a glass which has a refractive index is equal to 1.45, and you are asked to find out the critical angle of the glass. Okay, then we can write the formula sine C is equal to 1 by N, then C is equal to sine inverse 1 by N. Okay, putting the values, sine inverse 1 by 1.45, and you will find the result that is about 43.6 degree. Okay, this is how you can find out the critical angle when the refractive index of the medium is given. Okay, now we are moving towards an investigation to find out the total internal reflection. For this investigation, we will need a semicircular glass block and a ray box as a source of light. Okay, make sure the light strikes the boundary in the straight edge, and the light strikes the boundary the light strikes the midpoint of the straight edge. Okay, এই straight edge যেন মিড পয়েন্টে স্ট্রাইক করে, এটা রিজনটা কি? what is the reason behind this? রিজনটা হচ্ছে, যেহেতু এটা since it's a semicircular glass block, if you can direct the ray so that it strikes the midpoint of the straight edge, it strikes the boundary of the circle at right angles. Therefore, in this situation, no refraction occurs. The light straight passes through the glass block. And to find out the critical angle, you just need to increase and decrease the angle and find out the smallest angle, for which just move the ray box, but make sure the ray strikes the midpoint of the straight edge so that no refraction occurs at this point. Okay, so then move the ray box to increase or decrease the angle so that and so that the ray strike the midpoint of the center of the midpoint of the straight edge, and also the smallest angle. Find out the smallest angle for which the refracted ray runs along the boundary. That means the angle of refraction will be 90 degrees. Okay, this is the critical angle. This is how we can investigate how critical angle can be measured or investigated. Okay, now we are going to discuss about the uses of total internal reflection. Okay, আমরা এখন total internal reflection use দেখব, and now we'll see the total internal reflection of light in prism. Okay, if you place a prism this way and target a ray of light from a ray box or laser, this is the surface A, B, and C. Look at this diagram. The light is striking the side AB perpendicularly. Therefore, no refraction occurs at this point. Okay, and the light passes straight on and strikes at this boundary with an angle of 45 degrees. Okay, and we have already said that the typical critical angle is 42 degrees. Okay, the critical angle for typical glass is around 42 degrees, and in this case the light is striking the boundary between more dense to less dense medium with an angle of 45 degrees, that is greater than critical angle. So the light is totally internally reflected. Therefore, the angle of reflection will also be 45 degrees, and when the light strikes at this boundary, it strikes the boundary with an angle of 90 degrees, perpendicularly striking the boundary. Therefore, no refraction occurs. The light passes straight on. The light continues straight on. In this diagram, we have seen that the prism rotates the light or turns the light around 90 degrees. You can use the prism to change the direction of light to 90 degrees. Okay, and now we'll see how a prism can turn the light around 180 degrees. Okay, for this you have to place the prism in this way. This is the side A, B, C. Light from a laser or ray box striking this side perpendicularly, no refraction occurs. The light continues straight on, and it strikes at this boundary with an angle of 45 degrees, which is greater than critical angle. So the light is totally internally reflected. No refraction occurs. Totally internally reflected. The angle of reflection will be 45 degrees, and the same thing happens at this boundary. Okay, at this boundary the light is again striking the boundary with an angle of 45 degrees, which is again greater than critical angle. So again totally internally reflected. Okay, and the light then strikes at this boundary normally. Therefore, the light continues straight on without bending. So in this diagram we can see that the light is rotated to 180 degrees. Okay, you can change the direction of light using a prism to 180 degrees. Okay, now we'll discuss about some uses of this phenomenon. This phenomenon of the light can be used in bicycle reflector. Okay, bicycle reflectors use the property of light total internal reflection. Okay, this property is also used in prismatic periscope. Now we'll learn how to construct a prismatic periscope. Okay, first Okay, this is the first prism, and it is placed in a way so that the light coming from any source strikes the boundary normally. Therefore, no refraction occurs or no bending occurs at this side, and it is continues straight on. When it strikes at this boundary, it strikes at this boundary with an angle of 45 degree, which is greater than critical angle, and this is glass and this is air. So while traveling from more dense to less dense medium, the light is striking the boundary with an angle of 45 degree, which is greater than critical angle. Therefore, it will be totally internally reflected. Okay, the angle of reflection will also be 45 degree. The light continues straight on and again striking at this boundary perpendicularly. Therefore, no diffraction occurs at this side. It continues straight on. Okay, so the first prism has rotated the light around to 90 degree. Okay, you have changed the direction. The first prism has changed the direction of the light to 90 degree, and the second prism will be placed like this. Okay, again the light is striking the boundary perpendicularly, so continues straight on, and at this boundary it strikes at 45 degree, which is greater than critical angle, and again totally internally reflected. So it strikes this boundary perpendicularly, so continues straight on. Therefore, we can say that from this diagram we see that the direction of the light is finally parallel to the original direction. Okay, this is the source from which light is coming, and we can see from this point. Okay, the first prism has rotated the light around 90 degree, and the second prism again rotated the light about again at to 90 degree, but in opposite manner, so that the final ray or the final direction of the ray is actually parallel to the initial one. Therefore, you can see the image of the object from this point. What is the use of this periscope? We have already learned the mechanism of periscope that uses mirrors, but the prismatic periscope forms images that are brighter and sharper than those produced by periscope made of mirrors. Okay, prismatic periscope, this is how it works. Okay, now we'll learn the total internal reflection or use of total internal reflection in optical fibers. Optical fiber is a thin glass tube, or we can say a thin glass fiber composed of two glasses. This is called the inner core, which is made of optically more dense medium. Inner core made of optically more dense medium, and it has a coating which is called cladding, outer cladding, that is made of optically less dense medium. And since the fiber is very thin, the light always enters the fiber and strikes the boundary between the two media with an angle that is always greater than critical angle. Since it is very thin, the light entering the fiber and striking the boundary with an angle that is greater than critical angle, therefore totally internally reflected. Again, when it tends to travel from more dense to less dense medium, it again is striking the boundary with an angle that is greater than critical angle, so therefore again totally internally reflected. and it happens repeatedly until the light emerges from the other end. This is how an optical fiber works. Okay, and where it is used, optical fibers are used in telecommunication, where the signal is passed along the fiber as pulses of light, rather than sending signals as electrical signal through telephone lines or electrical wires. Because when you send signal through optical fibers, the signal, no signal is lost from the optical fibers, because the medium doesn't absorb that much energy from the signal. And that's why nowadays a telecommunication system uses optical fibers to transmit information or transmit signal from one part of the earth to another part. Okay, and optical fiber is also used in endoscope. You know what is endoscope? The doctor uses endoscope to see the inner part of the body without cutting the stomach open. Suppose you have some problem in your stomach and the doctor wants to find out what's actually going on there, and to do this, the doctor either has to cut your stomach or cut your body, or he can also investigate the internal part of your stomach by using an endoscope. An endoscope actually is a machine or is an instrument that is composed of two optical fibers. Okay. One optical fibers, another optical fibers, and there is a lens there. Okay, since there is no light source within your body, the doctor can't see what is going on within your stomach. So the endoscope actually consists of two optical fibers. One takes light along to the inside part of your body, and in this case, again, total internal reflection occurs, and this is the inner part of your body, and light being reflected from the inner part then comes along the second optical fiber, and the doctor can see the inner part of your body. Okay, this is how an endoscope works. Okay, so we have discussed the total internal reflection and its uses. So this is the end of the chapter 12, light waves, and you will have homework. Okay, solve the question answer of the chapter and submit it within 2 or 3 days. Okay, see you. Allah Hafiz, and we'll be next discussing with another topic, chapter 13, in the next video. Allah Hafiz.